Okay, welcome back to Mr. Hassan's Maths channel. I'm now going to answer question number 9 from the October 2022 Pure Mathematics P2 paper from Edexcel, International A-Level. And this question here is about this circle and this curve and the straight line. And it tells us that the curve C1 has the equation y equals x cubed minus 5x squared plus 3x plus 14. The circle C2 has a center T, and the point T is a minimum turning point of the curve C1. Using figure 3 and calculus, find the coordinates of T. So basically, T is the turning point of the curve, okay, the minimum turning point of this curve. So we want to find what the coordinates of T are. We need to find the place where the gradient of this curve is equal to 0. And it's going to be equal to 0 in two places. One is at the maximum, the other one is at the minimum. So we need to find the stationary point or the turning point of the curve. So we need to find the minimum turning point. That's what we need to find as we're told. Okay, so we've got to find the gradient at the turning point. The gradient is equal to 0. When in any type of curve, at the turning point, the gradient is equal to 0. And to find the gradient, we got to find dy dx. Now the function is already expressed in a form which is easy for us to differentiate. So we just have to multiply by the power. That gives us 3x, and take 1 from the power, 3x squared. And minus 10x to the power of 1. And the x term, just you drop the x and the constant term becomes 0. So when this is equal to 0, those will tell you the coordinates of x, the x coordinates where the turning point is, where the gradient is 0. It will tell us the x coordinates of the turning points. So you have 3x squared minus 10x plus 3 equals 0. So we got to solve this quadratic equation and find the values of x. Now what you can't do is just put this into your calculator and give the answer using the function button. You can either factorize or complete the square. Okay, to solve this, to factorize this, you can do it by guess and check, or you can do it by splitting the middle term. This is another form of splitting the middle term which I like to use, this kind of window method. So I'll write that the 3x squared term on this window and the plus 3 in this window, and I'll multiply them together. That gives me 9x squared, and I have to find two numbers. These two numbers multiply to give me that 9x squared, but when I add them I get the middle term, which is negative 10x. So of course two numbers are multiplied to give me plus 9, and when you add them you get minus 10. Well, they're both negative. It must basically 9x and 1x. When I multiply them together, I get positive 9x squared. When I add them, I get negative 10x. So now I'm going to take out the common factor of these two terms and write it over here. That's 3 and x. And once I've done that, the rest is very simple. I know that this number here must be multiplied, this term here and this term multiplied to give me 3x squared, so that must be x. This multiplied by this term gives me minus 9x, that must be minus 3. And x times this gives me minus x, that's minus 1. So we end up with x minus 3 and 3x minus 1 are our two factors. So we can say that either x minus 3 is equal to 0 or 3x minus 1 is equal to 0, in which case x is either equal to 3 or x equals negative 1/3. And we can see from the diagram, okay, it says, using figure 3 and calculus, we can see from the diagram that, of course, the maximum is 1/3 and the minimum must be 3, okay, because the maximum comes before the minimum. We can see that from the fact it's cubic as well, and a cubic that goes like this, the maximum comes before the minimum. Okay, so the maximum is x value is less than the minimum, so therefore the maximum x equals 3 is the maximum turning point, is the maximum. Okay, so we can now find what the value of y, the y coordinate. So when x equals 3, y equals, so we substitute 3 cubed minus 5 times 3 squared plus 3 times 3 plus 14. And that will give us the y coordinate. And then we have found the coordinates of t. So we can just put this into the calculator. So we have 3 cubed minus 5 times 3 squared plus 3 times 3 plus 14. That gives us 5. So we can say, therefore, the coordinates of t are 3 and 5. We don't really have to justify that this is the minimum here, although we could do if you wanted to, because we can see from the diagram, and it says use the point t and what does it say? Using figure 3 and calculus. So using calculus, which we did to find the coordinates of the two turning points, the x coordinates, and the figure. We can see from the figure this must be 3 and this must be 1/3. Okay, so those are the coordinates of t. That answers part A of this question. Now we're going to move on to part B. Now part B says the curve C1 intersects the curve C2 at the point A with x coordinate 2. Find an equation for the circle C2. So we know the coordinates of the point A are 2 and something. 2 and y. We don't know what y is. So we can work that out by substituting that into this equation, because we know that the curve passes through the point A. Okay, so A to y, it lies on the curve, on C1. Therefore, it satisfies the equation of the curve. So when I replace x with 2, when x equals 2, y is going to be 2 cubed minus 5 times 2 squared plus 3 times 2 plus 14. So I think I already have that set up. I have to just replace this 3 with a 2 now. Over here, that should give me the y coordinate of A, which is 8. So y equals 8. So the coordinates of A are 2 and 8. Now, how does that help us here? Well, it helps us because to find the equation of a circle, we need two things. Okay, we need two things. To find the equation of a circle, we need to have 1, we need the radius of the circle, and 2, we need the center of the circle. Those are the two things we have. Now the center of the circle is t. We know that already. The radius is the magnitude of the length between A and T, which is going to be the square root of, now we know A is 2, 8, and we know T is 3, 5. So it's the length between these two. That would be the radius. Okay, so we have 2 minus 3, or we can say 3 minus 2. This is 1 squared plus, and when you subtract that, you're going to get 3. Negative 3 doesn't matter. You're going to square. It's going to give you 3 squared. It's going to become positive anyway. So that's going to give you the radius. So the radius is equal to the square root of 1 plus 9, which is 10. So the radius is equal to root 10. And we know the formula for the equation of a circle is x minus a squared plus y minus b squared equals r squared. That's the equation for the circle. Okay, that's the form. So an A and B is the center, and R is the radius. So here we have all of that. We have A is the x coordinate of the center, which is 3. So x minus 3 squared plus, and B is the y coordinate of the center, which is 5. Y minus 5 squared equals R squared. That's going to be 10. So there is the equation of C2. The equation of the circle, C2, x minus 3 squared plus y minus 5 squared equals 10. All right, so there's part B answered. Now for part C. Part C says the line L shown in figure 3 is a tangent to the circle C2 at A. And we know the coordinates of A were 2 and 8. Let's just make sure of that. 2 and 8, that's right. And we know the coordinates of T are C5. All right, so show that the equation of L is a third x plus 22 over 3. A third x plus 22 over 3. Okay, so now, the equation of line L. L is a tangent to the circle. Now, the tangent to a circle basically has the same gradient of the circle at the point where it touches it. And what we know is, one very important point about circles is that the gradient of the tangent and the gradient of the normal are perpendicular. So if I know the gradient of the line AT, I know the gradient of L, okay, is perpendicular to the gradient of AT. or I can say L is perpendicular to AT. You can say the line L is perpendicular to the line AT. All right, because that's the tangent, that's the normal. The normal is, we know the radius meets the tangent at 90 degrees. Okay, the tangent meets the radius at 90 degrees. So if I know the gradient of AT, then I can work out the gradient of L, because the gradient of the line L times the gradient of AT will give you -1. They're negative reciprocals. Okay, so the gradient of AT. Now we know that T is a 0.35 and A is a 0.28. So the gradient of AT is a change in Y, which you can say is 8 minus 5 over the change in X, which is 2 minus 3. That gives you minus 3 over, so that gives you 3 over -1. 3 over -1, which is -3. Therefore, the gradient of the line that we're looking for is, its gradient is 1/3. The negative reciprocal. Third times -3 is 1, -1. So now, to find the equation of a straight line, we need two things. We need the gradient of the line, and we need any point on that line. And we know that point A is on that line, which is the point 2, 8. Okay, and this is 1/3. So then we can use the formula y minus y1 equals m times x minus x1. So y minus the y coordinate of the point that we know, which is 8, equals m, which is 1/3, times x minus the x coordinate of the point, which is 2. Okay, so now if we want to write this in the form y equals mx plus c like this, we have to show this exactly. So we don't just write the answer down after this, because they've told us to show this. So we have to go through the steps of showing how we get there, right? So you have y minus 8 equals 1/3 x minus 2/3. And then I would show here that you have minus 2/3 plus 8. Now 8 is the same as 24 over 3. Right, just getting it ready to add the two fractions. So y equals 1/3 x plus 22 over 3. And that's as required, we've shown it. Okay, so there's the answer to part C. We've shown that the equation of the line L, which is the tangent to the curve at C, to the circle at C, is given by this formula here. And that concludes question part C. Now for part D. It says the region R shown shaded. Okay, we know the coordinates of A were 2, 8, and the coordinates of T were 3, 5. I haven't written down here. And the equation of the line was y equals 1/3 x plus 22 over 3. All right. Okay. All right. So it says the region R shown shaded in figure 3 is bounded by C1, L, and the y-axis. Find the exact area of R. Okay. So it's bounded by these three lines. So now what I need to do is to find this area here. Now, normally when you have a curve and a line, to find the area enclosed between them, what you could do is subtract these two equations from each other and then integrate between the limits where they intersect. Now, I think that's going to be a bit of a hassle here to find the coordinates of where they intersect. Okay, you could do it. It won't be a problem. You have to just basically replace the y here with 1/3 x plus 22 over 3, and then solve the equation. This is a cubic equation which will have 3 solutions. Okay, one of the solutions we know already, so we can use that to find the other 2, and we'll know that this is negative. But that's going to be a bit of hassle. It's only worth 3 marks. So using the algebraic long division and all that, it's going to be a bit of hassle to find that. Okay, and then the problem is with that, when you find that area between them, you end up with this part here, which you've got to take away from it. Okay, so then you've got to basically, take away this part of the area from that thing, because the area, when you equate them, you get the area where they intersect, enclosed between them. So that's going to be even more hassle. So it's a lot of hassle even finding the points where they intersect. Okay, and then it'll be even more hassle. So it'll be a lot of hassle. So the easiest thing I think to do is, we already know A coordinate is 2. So I'll just put a little line here. I think this is a sensible thing to do here. We already know the coordinates of A x coordinate of A is 2. We know that. Okay, so we know that. Okay, so this is 2 here. And we know the point here is 0, of course. So if I integrate this curve, if I find the area under the curve between 0 and 2, I'll find the whole of this area, but it will be also including the area in this section here. It will also be including this trapezium, basically. Okay, it will be including this trapezium. So we've got to subtract the area of this trapezium from the area of what we find when we integrate this between the limits of 0 and 2. So what we need to do is we need to integrate our curve C1, okay, which is x cubed minus 5x squared plus 3x plus 14 with respect to x between the limits of 0 and 2. And we've got to take away from that the area of this trapezium. I'll say area of this. This is like a trapezium. Okay, this trapezium here. Okay, and I know that this is the line, okay, L1, which passes through the y-axis at 22/3. So this, I know the coordinates of this point is 22/3. I know the coordinates of this point is 2, 8. So that's 8. So I can work out the area of the trapezium quite easily. Okay, so let's start off with the integral of this. So I need to integrate this between the limits of 0 and 2. So I'm going to change this to a square bracket because I'm going to start integrating straight away. X to the power 4/4. You add 1 to the power and divide by the new power. Minus 5x cubed over 3. Plus 3x squared over 2. Plus the constant term gains in x. You don't have to put plus c because you have a definite integral here. I'll just put those limits here to 0. Minus the area of the trapezium, which is the distance between the parallel sides, which is 2/2. Half of it's like the area of a trapezium is h/2 times a plus b. So it's the distance between the parallel sides, which is, these are the parallel sides here. So it's 2/2 times the sum of the parallel sides, which is basically this length, which is 22/3, plus this length, which is 8. That's the area of the trapezium. So this should give us our required area. So now I've got to put 2 in here and 0 in here. Now putting 0 in here, everything's going to become 0. So I just have to worry about putting 2 in there. So I'm going to have 2 to the power 4, which is 16/4, minus 5 times 2 cubed, which is 8/3, plus 3 times 2 squared, which is 4/2, plus 14 times 2. And I've got to take away from that 22/3 plus 8. That's going to be 22/3 plus 24/3. That's 46/3, right? 22/3 plus. So I can actually just put this right into my calculator. Okay, let me just put this into my calculator and see what we get. So now I'll start from here because that's 8, that's 4. That should be fine. Okay, I don't think I've made any silly mistakes there. So I have 16/4, which is 4. Oops. 16/4. That's going to give me 4. Minus, I have 5 times 8/3. I have plus, that's 3 times 4/12. That's going to be over 2. So that's 12/2, which is 6. I'll just put 6. That's easy anyway. Plus 28. Close that bracket. Minus, I'll just, to be sure, 22/3. Keep that in a bracket so it's protected from the minus sign, plus 8. Okay, now when I put that in my calculator, that should give me my final answer, which is 28/3. So we can say, therefore, that's 28/3. Therefore, the area of R is equal to 28/3 square units. Okay, so find the exact area of R. So they want you to round it or to write it in decimal form. and round it. They want to leave it in this fractional form. You can write it as a mixed number if you want, but that's fine. So there is the answer to part D of this question. And that concludes this question number 9 from the October 2022 Pure Mathematics P2 exam. Other questions from this paper can be found in the playlist that will appear in this region over here. Other questions can be about the topics of, I guess there's a lot of different topics here. So you're going to have circles, you're going to have differentiation, and I guess you're going to have integration. All right. There's also that part of circles, also finding the equation of the tangent to the circle is part of that. So those 3 topics are covered in this one question. All right. So that concludes the question. Thank you for watching, and see you soon.